Hello there guys, welcome back to our fourth tutorial about developing a game in LibGDX. So in the previous video we managed to run some touch interface, okay, and we got something like this. Let me show you. Okay, so we can click here or touch this part or touch this part and get our spaceship rendering without a problem, right? So this is all nice and good for our case. Now let us try to improve this further. Now one of the issues that we had is we can't debug the code, so debug wasn't hitting this. So I managed to solve the issue. All I had to do is go to run and edit configuration. I had something here. Let me remove this and show you what I was missing. So I had something like this. So all you have to do is click add here, make sure to select application, so give it a name. I'll give it a name desktop. Okay, now the main class, you click the ellipses and it will suggest the desktop launcher. Give it an OK. That's fine. Now the working directory, open this one, make sure to open this and select the assets folder and Android. This is assets folder. Now this is suggested by LibGDX website. And last thing, there is a user class path module. Make sure to select the desktop module, and that's it. You hit OK. So now if you debug your application, okay, the breakpoint got hit. So we can now press F8 and perform tracing and know what is going on in our code. Very straightforward. Okay, I don't know why such configuration is missing, but this is how you could solve this issue. Very straightforward, very nice. Okay, we need that a lot. So let's stop this. Stop the other one. Seems like there are some processes in there. Okay, so now that is said, let's go back to our code and try to improve things a little bit. So let's run this again. Okay, now we got this. This is fine. Now let me show you this. If I select the Android project, run this on Nexus emulator. So now the Nexus emulator is starting, and let me just flip the game like that, or the emulator. So we'll have to wait a few seconds to see the problem. The problem I want you to see is the scaling of the game on different machines. Okay, so come on. Okay, sorry. So let me just rotate this and rotate it again. Okay, there you go. So you can see now the problem of scaling. You can see now the screen should be something like this, and the scaling here, because this phone has very large resolution, we are getting something like this. So this is not in our favor, because if you want to address this, I suppose there are many ways, but one of the ways that I use is to create a virtual buffer, okay, which I assume is the display or the standard display size, okay, and I work on that. Now what happens is that after I render everything into that buffer, I will stretch it and place it on top of the screen, so everything will be almost like the same on different devices and different screen sizes. Okay, in theory it's not exactly the same, but close enough and acceptable enough, I suppose. Okay, so let's try to solve this issue in this video. Okay, and I will delay the sprites to later. So let me stop this, stop the Android, sorry. and stop the desktop process. Okay, so managed to stop both of these. Good. Now, in order to address this in the game, we will add something new. Let me add, yeah, I already wrote it here. Yeah, sorry for that. I will define something called a frame buffer. Okay, and this will represent a virtual display. Okay, so this is a frame buffer. Okay, and I will just put a note. Maybe I should put a note in the front of everything. Okay, just to make it more readable. So what this one does, or maybe wait a second, used to render objects. Okay, now spaceship texture. Okay, used to manage input. Okay, now used for motion will be removed later. Now virtual display. So we have this one, and we are going to define something important here, which is public static int virtual width equals, I'll make it 800 pixels, and public static int virtual height equals 600 pixels. Okay, so I'll assume there is a virtual width and virtual height for this virtual display, and also I will have texture region, something called texture region. Oops, texture region. Okay, virtual region equals null. Sorry about that. So in the initialization part, what are we going to do? So I will do the following. I'll say virtual display equals new frame buffer. Open this one. Sorry. Yeah. So let me see. I think let me see. I kind of forgot how to construct this. Yeah, right. So let me have a look, because it has been a while. I remember frame buffer, but can't remember frame buffer. Okay, give you some documentation to that, but yeah, it doesn't show me anything. New frame buffer. Maybe I should state like texture. Yeah, let me check this. Okay, just say here I should be able to create this one, frame buffer. I don't get any hint for, oh, there we go. So now it is showing me the tooltip telling me what this one is. So I need to provide the format of the buffer. In other words, what kind of you know, storage or how the bytes are used for this buffer. So this is going to be format dot, and here I will use RGBA 8888, so I will use 32 bits. Okay, now the width is going to be virtual width. Okay, and the height is going to be virtual height, right? So has depth. This is going to be false. Okay, and semicolon. So we created our virtual display. That's fine. Now we are now going to use the virtual region, or define the virtual region equals virtual display dot get color buffer texture, I suppose. Yes. Okay. So right, yeah, I suppose this is it. Let me see. Right, or what? Virtual display get what? Get the buffer, frame buffer, handle, height, texture, attachments. Yeah, I think it was the color buffer texture, right? Yeah, something like that. And there should be a semicolon here. Okay, so here, yeah, requires combat logic GDX graphics 2D texture region. So maybe ports texture region. Yeah, define. This is defined here. Okay, what does this one return? Let me see. Okay, let me see this one. What does it return? Okay, so maybe, well, actually, yeah, virtual region, I'll define it as texture. That's it. If it is require different type, it's gonna be texture. Okay, I suppose that's it. Yeah, it's working fine. Okay, so for now, in order to test this, okay, right now let me run this on desktop. Let me show you. We didn't do much so far, but let's have a look. So everything still works fine. Now, what are we gonna do is instruct LibGDX to render things not on the display, but rather into the texture here, virtual region. To do that, you do something that is very simple. Just say virtual region dot begin, right? Let me see. Begin. Oh no, I see. Okay, I think, wait a second, virtual region dot get region. How is that? Get texture. Wow, seriously, I'm forgetting lots of things. Yeah. Dot get depth, height, width is managed, load. Unsave class notify, wait, cast field. Okay, so just wait a second. I will use the net again. So here, okay, get texture region from frame buffer libgdx. There you go. And yeah, it was something I checked earlier. So in new blah blah blah, in new texture region, oh, a new texture region, and I passed the buffer into it. I see. A new texture region, and I passed the buffer into that. So a new, so this should be back to the way it was. Texture region, there you go. So this is gonna be new texture region, and I passed this into it, right? And there was something else. We enable flipping, I suppose. Yeah. So virtual region dot flip let me see, flip false true. Oh, I think this flips the direction. Interesting. Okay, no problem. So we will have a test here. So let's go back, and now I'm gonna say virtual region dot begin, or yeah, right. Isn't that right? Oh, sorry. I was using the wrong thing here. I just need to do the following. Just need to say virtual display, not the region. Yeah, begin. And after I finish everything, I just say virtual display dot end. So basically here we are telling our game engine to draw not to the display but rather to our virtual display. Start rendering to the virtual display, and here and rendering to the virtual display. So now there is no part here that we are drawing to the screen itself, so we should see nothing. So let's have a look. And we have a black screen, but everything is working. So what we need to do next is to draw things into our screen. So when you finish this one, the rendering goes back to our main screen. To draw or render the virtual display to the actual device display. So what are we gonna do is something that is very simple. We will just say batch dot begin and batch dot draw. Now I will pass what? The virtual region, there you go, followed by 0, followed by 0, followed by, I suppose it's going to be virtual width, followed by virtual height. Yes, and that's it. And then batch dot end, right? And there you go. So this should be it, I suppose. I'm not sure, but let's see. Let's run this. Okay, now things are being rendered, but they're out of proportion, and we haven't, you know, done good things here so far, right? So what we need to do is, you know, scale things to the actual display itself, right? So we will try to make something about the scale right now. So here we will just do a few things. So we have integer physical. Let me make this also public static. Physical width, semicolon, and public static int physical height. Okay, and public static float, scale x, and public static float scale y. Okay, so now we have two scales, right? You can see physical width and height, and yeah, I will use these to make my life easier. So after I create these things here, I will just say physical width equals libgdx dot graphics, oops, sorry, gdx dot graphics get width, very nice, and also physical height equals gdx dot graphics get height, semicolon. Now I got these two guys. Next I will calculate the percentage needed for scaling. So now scale x equals virtual width, divide this, yeah, by the way, this needs to be float, and divide this by what? Physical width, right? Yes. And scale y equals float and divide this by virtual height, right? Physical height, there you go. So we have now scale x and scale y and so on. So now let's go to this draw method and see what other constructor do we have. Okay, so let me see this for a second now. Okay, so here oops, I need to be on the same line. Okay, come on, complete what I'm typing here. Okay, good. So we have the float xy. Which one has, yeah, it is this one. I suppose it's this one. Okay, it's this one because it has scaling. So I need to specify 0 here, followed by 0 here, followed by the origin x. Now the origin is at point 0 again, and this other one's origin is also at 0. Now the width, now the width doesn't say the width of what. I'm gonna say physical, I'll assume it's the physical width followed by physical height. I assume that. Okay, I'll have to check the documentation just to make sure. And the scale x, so there's going to be scale x followed by scale y, and also the rotation 0 degrees. Don't want to rotate anything at all, and semicolon here. Okay, so let me save this, and now let's run. Now come on, please run well. Okay, I'm not sure if anything is working fine, so I have to check the documentation. Please bear with me for a second, please. Should I say this is virtual width? Oh, let me say virtual width. Virtual width. There you go. This is gonna be virtual height. Yeah, so virtual width, virtual height, and let's run this again. Yeah, I think the previous one was accurate. I think. Sorry about that. Just knocked the mic. So let me check this quickly. Okay, so I have these two. Maybe this one. Okay, so let's see the draw batch.draw. So libgdx, or wait a second, I could actually check this one, the width and height. Where is the width and height? The graphics. Oh, so the that's weird. Okay, so here I'm gonna say libgdx, right? Batch.draw. Okay. Yeah, it's a private batch. So where is the draw method? Begin. Okay, so draw. The one we are interested in is not texture region. Where's this one? Yeah, it's this one. Yeah, it draws. It draws a rectangle with the bottom left corner at X, Y, and stretch the region to cover the given width and height. Okay, and stretches the region. So in theory, I shouldn't have to do anything at all. Actually, I don't need these three parameters, right? Maybe this is what I am supposed to do. I suppose this is it. And then why this one's objecting? Let me see. Let me have a look. This is texture region. Yeah, this is a region, right? So we have X, Y, X and Y, origin X, origin Y, width, height. Oh, sorry, my mistake. No, I need that. Actually, I still need that. Okay, so is there an example here? Given width and height. Okay, so is there an example to the draw here? Yeah, I wish they could give a good example. Yeah, so this is the example. Draws a rectangle with the bottom left corner X, Y, and stretch the region to cover the given width and height. The rectangle is offset by origin X and origin Y relative to the origin. Scale specify the scaling factor by which the rectangle should be scaled around the origin X and origin Y. Rotation specify the angle of rotation clockwise. Okay, so in theory this should be accurate. Okay, now you might be wondering, where are the buttons? Well, the buttons are using fixed positioning, so this is why they don't appear. So let me try to run this on Android and see what are we gonna get. So this is the first one. Let's see what are we going to get on Android. And okay, that's painful. Okay, so we made a big mistake. So it seems that our scaling ratio is reversed. Okay, so I just need to reverse that. Let's fix this very quickly. Come on. Okay, so this one goes here, this one goes here, this one goes here, this one goes here. Okay, so now let us run this. Okay, come on, please work well. Okay, now this is the first one. Now let us run this as desktop application. Okay, now this is embarrassing actually. Now okay, so let me explain the problem right here. Seems that the scaling here, I'm having a problem with the scaling, so I have to check the width and height of the devices and make sure that the scaling is working correctly. Okay, I'm doing some kind of mistake. So let me check this and see what is happening. So let's see at the scaling here. I'll stop this for the desktop. Yeah, also close this one, and also I'll stop. Come on, dude. Okay, so I stopped all of these. Now I will debug the desktop application just to see what is going on. Okay, so now what do we have? We have the physical width 640 and the virtual width is 800. Okay, and what's the scale in here? Okay, so this is gonna be f8. Okay, so here the scaling is 0.8. meaning that the display should be, you know, scaled down a bit, 0.8. Now let's see this one, 480, this is 600 here, this is 0.8, so about 0.8, this is what's happening. So let me put a breakpoint here, and origin, this be physical, wait a second, 0, origin, the width and height. Yeah, let me check this, the width and height. What's the width here? Yeah, I'm not sure. Okay, let's see what's going on here. So now let's say F9 if I'm not mistaken. Yeah, so the physical width 640 and the scale Y is 8, right? And this should be it, I suppose. Okay, so let me move the breakpoint and F9. Let's have a look. Yes, so yeah, that's a problem. Okay, so I'll change this into virtual width and this into virtual height. Okay, let's have a look now. Stop this and run this here. Documentation is not clear enough. Now this one looks to be seems to be okay for now. Now let me change this into Android and see, hopefully, yeah, I ruined it. Yeah, okay. Let me repeat this, put this into the desktop coordinates and run this. Yeah, I'm doing some kind of mistake, I'm sure. Very sure about that. Right. Okay, so I will make something different. Okay, rendering the buttons, rendering these buttons is causing some kind of issue. Okay, because I am using the display coordinates when I am trying to render them. Okay, although I'm using get width and height, it should get the virtual width and height. That's confusing. Okay, let me stop this for a second. Let's stop the code here, and let me go to render. Yeah. Yeah, I might be doing something wrong. Not might be, definitely doing something wrong. So let's see. So we get a new texture, left mouse button, the X one, and okay, so this one, graphics get width. No. This is gonna be G01 dot what? Virtual width. Yeah, that should be it. Minus this, blah blah blah. Right? And this need to be get width, get height. Yeah. So the last thing we need to do is keep press, blah blah blah. Okay. So through mouse graphics, get height. Now this is gonna be G01 game dot virtual, virtual height, right? Minus this, minus blah blah blah. That's fine. Again, this is gonna be our virtual G01 game virtual height. Yeah, get height. Yeah, I suppose this should be it. Let me run this as desktop application and see Okay, so I think now we are getting a better picture. So here, this is gonna be physical width, and this is gonna be physical height, something like that. Okay, so now let's run this. What a disappointment. It still refuses to display everything. This is very weird, right? Because I'm trying to, you know, draw everything here. Okay, so let's see what happens to Android. I change this to Android and run. Restart Android. Yeah. If I still get the problem, I will just keep this and I will debug this later on. I'm definitely doing something wrong. Okay, so this is very promising. If you have a look at the Android device now, the game is being scaled well on the Android device. As for the desktop, it doesn't appear to be so. Very interesting, right? Okay, so now let me run this again, but I'll restart this. I will use another virtual machine. I think I can do that, right? The system image is missing. Download? No, don't download. We just need this one. We don't want anything else. Yeah, I'm not sure, but I think this is okay enough. I think we are already doing it right, but there is a problem maybe with the desktop display here. Okay, this is what my thinking is telling me. Okay, oh, come on, what did happen here? Okay, so I think we finished this one. The scaling problem is being solved, but there is a problem with the you know, desktop application. So I will have to check this and come back to you guys later on. But for now, look at what we have done. We simply managed to get rid of the scaling problem for different Android devices. So let us do the following. I will just try to create a new device with different resolution. So I'll power off this one. And where is that? I think it's this one. Yes. So Nexus 5. So maybe I could create a new virtual device. Come on. This is gonna be Nexus 5. I think I could choose something different. Right. Let me choose this one, Galaxy Nexus. So instead of 1080 9020, I will try this one. I hope I already have this device. Oreo, whatever. Next. And Galaxy Nexus, blah, blah, blah. Yeah. Finish. And please don't tell me you're gonna download things. Please, 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 please. Okay, so let me now run this game on the Galaxy Nexus. Okay, so I will just close this one, run. Now Galaxy Nexus, give it an okay. Let's have a look. Just wait for a second, please. Let's see if it works on two different Android screen resolutions giving the same output, then we already solved the issue. Okay, so I suppose, come on dude. Yeah, just wait a second, please. I'm just making the final test to make sure that the problem is with the desktop application resolution, not with our own work. And actually we could do something simple like checking the desktop, or if it's a desktop application then just, you know, use, yeah, I think we already nailed it. So let me run this on Android. To cut and restart this session, cancel. Oh, let me run this again. Restart. Now we will use this one, so we will have another one. So this is the first one, and the second emulator is running now, or preparing itself to run. So the game itself, where is the icon of the game? Where is the icon of the game? This is very interesting. Oh, it's here. This G01. Okay, so this is the first device, and this is the second device. Oops. Okay, yeah. So now we have two virtual devices, each one having its own resolution, and we should have the same rendering. Yeah, so as you can see, the rendering is almost the same for these two devices, okay? But there is a problem here. The buttons, you know, doesn't work that well because of the different resolution, okay? And the reason is that because the checking for a click is happening on the device native resolution, not the virtual resolution. Same thing goes here, okay? Yeah, so the second button is somewhere here. Okay, so we need to scale things here, and we will solve this issue by tomorrow. Okay, so we achieved our goal in this tutorial, and now we can render things you know, regardless of the resolution of the screen of the phone. Okay, so we solved this problem already. That will be all for today. Thank you for your patience and waiting for me to solve the problem, and have a nice day. Tomorrow we will fix the click on different resolutions issue. Okay, and we will see how we can scale things to solve this problem. Okay, so that when you have different resolution, we don't depend on the physical device resolution, but rather on the virtual device the virtual display resolution we use. Okay, now that will be all. Thank you again, and have a nice day. Bye bye.